In this video, we're going to look at rationalising the denominator of a fraction. Let's start off with the definition of a rational number. We can write a rational number in the form a over b, where a and b are integers. So for example, if we had 3 over 5, this is a rational number. 3 is an integer and 5 is an integer. If we had, for example, now root 3 over 7, we have a rational denominator but an irrational numerator. This is perfectly fine in terms of a convention in which we would write a surd where we have a fraction. If we had, for example, 2 over the root of 5, we would look to rationalise this fraction. That means that we would have an irrational number in the numerator but a rational number in the denominator. There are two types that we're going to look at in the video, but before we go on to them, I just want to look at a bit of background of why we rationalise the denominator. Let's go ahead and take a triangle. What we're going to have is an isosceles triangle. If I have now 1 here, so we'll call this length 1, and this length 1, if I put the right angle here, I'm going to have an angle here, x. Using basic Pythagoras, 1 squared plus 1 squared square rooted gives us now that the hypotenuse would be root 2. If we wanted to write down the sine of the angle x, the sine of the angle x is 1 over root 2. It's the opposite over the hypotenuse. So we'd write 1 over root 2. If I type in 1 over root 2 in my calculator, it's going to rationalise the denominator of that fraction for me, and it will give me root 2 over 2. So if you type in now 1 over root 2, we're going to have now a rationalised denominator, and that's going to give us now root 2 over 2. Mathematicians like convention, and they've decided that we're going to take this convention of writing the fraction like so. In some situations, we would leave it like this, 1 over root 2. So for example, in trigonometry, as I've just done here, this is perfectly fine. The advantage of writing root 2 over 2 is that we can see the rough size of this fraction. The root of 2 is about, give or take, 1.4. 1.4 divided by 2 is about 0.7. If we look at it in this particular form, 1 divided by 1.4, that is harder to see. So mathematicians decided on the convention that we would rationalise the denominator, and this is one of the many reasons that it's advantageous. If you want to look on the internet, you'll find all manner of debate of why we should do it, but this is a pretty good reason. So depending on whether you want to argue or not is entirely up to you, but for now we're going to just look at the techniques involved in rationalising fractions. We're going to look at 2 different examples, and I'm going to start with the first example. The first example is where we just have now a surd in the denominator. So for example now I've just got root 3. I've not got, for example, 2 plus root 3, or 5 minus root 3, or root 6 plus root 3. I've simply got a surd value. All we do in these particular cases to rationalise the denominator is multiply the numerator and the denominator by that value. Whatever we do to the top, we must do to the bottom to keep the value of the fraction the same. So let's go ahead and look at this one. So all I'm going to do is 1 multiplied by root 3 over root 3 multiplied by root 3. So all I've done to the fraction is multiply the numerator and the denominator by this value of root 3. So if we look at this now, what we're going to get here, and I'll just try and squeeze it in, 1 times by root 3 is root 3, and now root 3 times by root 3 is just going to give me 3. So if you wanted to type in 1 over root 3 into the calculator, that's what you're going to end up with. So 1 over the square root of 3 will give us root 3 over 3. What we'll also see, another advantage of these, is that we will have factors cancelling down in some cases. So this one right here, let's go ahead, 2 multiplied by the root of 5 over now the root of 5 multiplied by the root of 5, and that's going to give us now 2 lots of root 5 over 5. In all of the videos we've seen now that the root of a multiplied by the root of a is a. I'm now assuming that you're fairly comfortable with that. Okay, let's move on to this one. Right, with this one here, what we've got is 3 over 4 lots of the root of 7. We don't need to multiply the numerator and the denominator by 4 root 7, we'll just multiply it by the root 7. So we'll have 3 multiplied by the root 7, and that will be over 4 multiplied by the root 7 multiplied by the root 7. So that's going to give me in the numerator 3 lots of the root of 7, and in the denominator we're going to have 4 times 7, which is going to be 28. Again, if you want to check that as you're doing this on a calculator, 3 over 4 lots of the root of 7 is going to give us the value we've just found. So 3 root 7 over 28. Quite clearly this will be a non-calculator exercise initially, so you can show that you have the skills to do this. Okay, let's look at this one right here, 6 over 5 root 2. So we're just going to multiply the numerator and the denominator by the surd in the denominator, and that will give us now 5 root 2 times by root 2. By multiplying the denominator by this surd, we're simply now creating an integer value that makes the denominator of the fraction a rational number. 5 is a rational number, 3 is a rational number, 28 is a rational number. The numerator is irrational, but we're simply now going ahead and writing it in this form. So what we're going to have then is 6 root 2, and then in the denominator we're going to have 5 times by 2. That's going to give me now 10. At this stage what you could do is write that this is going to be 5 times by 2, and we can cancel down. If you want you can write 10. I'm simply going to write that this is 3 root 2 over 5, and the reason I've done that is that we can cancel the 6 and the 2 to give 3. If you want to write 10 and cancel it, you can do, but if I type this into a calculator, what we can do now is the following. We can write 6 over 5 root 2, and it will simplify after rationalising to give us 3 root 2 over 5, and we can see that. So there's another advantage, that those common factors can be cancelled off, and again it gives us a bit more of an idea of what this number looks like. So we've seen that root of 2 is 1.4, so this is going to be 3 lots of 1.4, which is going to give roughly 4.2 over 5, which gives us a much better idea of the magnitude, the size of that fraction, rather than a 6 over 5 lots of the root of 2. Okay, moving on. Let's have a look at this one now. What we've got here is 3 over 8 root t. This isn't a numeric value. I've simply introduced now t instead of a number. So we would multiply the numerator and the denominator by the root of t. That would give me 8 root t times by the root of t, which would now give us in the numerator 3 root t divided now by 8 lots of t. You can argue that that can be simplified using rules of indices if you wanted. It'd simply take us back to where we were though. But in terms of a rational denominator, this has been rationalised. Okay, let's look at this one right here. Now I've got 2 root 27 over 5 root 12. I'm thinking to myself here, do I really need to multiply the numerator and the denominator by root 12? You certainly could. What I'm looking at here though is that we've got some common factors, and I'm going to write this actually as 2 over 5, then it's going to be the root of 27 over 12. In a previous video we saw that the root of a over the root of b can be written as the root of a over b. So let's go ahead and write that that is going to be 2/5. So what can we divide this by? We can divide this now by 3 and 3. If I do that, what we've got now is the following. If I divide this one by 3, that's going to give me 9. If I divide this one by 3, that is going to give me 4. Okay, these are both square numbers, so we can write this now as 2 over 5, and then what we've got here is simply the square root of 9, which is going to give 3, and the square root of 4, which is going to give 2. These 2's are going to cancel, and that is actually going to leave me a rational fraction. So not just a rational denominator, a rational fraction. So if we go ahead and check that on the calculator, what we've got here is 2 the root of 27, and we're going to divide that by 5 lots of the root of 12. So if you look ahead, instead of multiplying this by root 12, what we can see is that this actually gives us 3/5. We've simplified. So do check and do be careful. We saw this property in a previous video, and I think this is quite a nice example. Okay, what are we going to do with this one right here? So a bit of extension work. I'm looking at this right now and thinking to myself, I'm going to multiply now the denominator out, tidy up, then multiply the numerator by this value here to see what we get. Okay, so what we're going to have then, let's just go ahead and write that this is going to be root 3. In the denominator, I'm going to get 1. Then I'm going to get on here now plus the root 27. At this stage, I could write the root of 27, as we've seen before, as 3 lots of the root of 3. So plus 3 root 3. Then I'm going to have on here minus 1 lot of root 3. So minus 1 lot of root 3. And now we've got a minus the root of 81. So minus root 81. So if we do a bit of tidying, that's going to be the root of 3. And then we've got now 1 minus the root of 81. The root of 81 is 9. So that's going to give me minus 8. So all I've done is taken the 1 and subtracted away 9. Then what I've got here is 3 root 3 minus 1 root 3, which is going to give me plus 2 root 3. This now leads us on to the next part of our learning. What we've got here is a denominator where we've got a surd value and also we've got a plus or minus sign. So how do we do these? Before, we simply multiplied the numerator and the denominator by the surd in the bottom of the fraction. I can't just multiply this by 2 root 3. What we're going to do is look at examples of this and then come back to this one. So let's just go ahead and look at rationalizing the second type of fraction. Hopefully you can see the difference. These have all got a single surd in, and these have a plus or minus between 2 values. So we might have one, for example now, where we have root 2 minus root 7. What we do here is use the difference of 2 squares, or we multiply it by the conjugate. The conjugate is the same numeric values with the sign changed. If I said now, and we saw this in a previous video, x plus 2 and x minus 2, and I expanded this out, we would get now x squared minus 2x plus 2x minus 4. The difference of squares now means that we're going to have no term in x. So this just becomes x squared minus 4. This is a square number, this is a square number, and that now is our difference. In order to rationalize the denominator of a fraction of this form, we multiply it now by the conjugate or the opposite, and it will get rid of the surd value. So let's start off with a nice straightforward one. 1 over 1 plus the root of 5. We multiply the numerator and the denominator by 1 minus the root of 5. So 1 minus the root of 5. What we'll see now is in the numerator we will just have 1 minus root 5. That's nice and straightforward. In the denominator I'm going to have 1, so multiplying this out as we saw in the last video, minus the root 5 plus the root 5, and then we're going to have now minus root 5 times by root 5 is going to give us 5 minus 5. These two terms drop out. That's going to leave us now in the numerator 1 minus the root of 5, And in the denominator, we're going to have 1 minus 5, which is minus 4. So that particular fraction, when rationalised, could look something like so. You might want to write this now. Let's just write it here. We could have now the root of 5 minus 1 over 4. I think it looks slightly better in this particular form by multiplying through by negative 1. But if we look at this in a calculator now, using our scientific calculator here, the Casio one, this will put it in exact form. So it shouldn't give me a decimal answer. It should give me one of these two, and I would have thought it will default to bringing the negative out here. So negative, there we go, that's this one right here. So negative 1 plus root 5 over 4. They've simply just, well, he, she, whatever the calculator is, has simply swapped this over. So that is how you rationalise the denominator. So if we look back, single surd, multiply numerator and denominator by that surd, with the 1 plus or minus, for example, or 2 plus or minus for surd, we multiply by the conjugate now, or if you like, you create the difference of two squares. So let's do the next one. 1 over 1 minus root 3. We multiply numerator and denominator by 1 plus root 3. 1 plus root 3. If you have an integer value here that is greater than 1, don't initially expand the brackets, as you might find that you can cancel further as you go. So what we're going to have then is 1 plus the root 3. In the denominator, I'm going to again do full workings. We'll have 1 plus the root 3 minus the root 3 minus 3. Depending on how many marks you're given in the exam, just be aware that you might have to show full workings. So the two surd values disappear. 1 plus the root of 3 over 1 minus 3, which is minus 2. And again, that can be written in many different forms if you wish. Okay, let's do this one. So what we've got then is 5 over 2 minus the root of 7. We're going to multiply the numerator and the denominator by 2 plus the root of 7. So 2 plus the root of 7. What I'll have then is 5 lots of 2 plus root 7. Then in the denominator, I'm not going to do this one right the way through, but all I'm going to have is just 4 minus 7. Remember, it's this number squared minus this number squared, and we've looked at that previously. So I could write this now as 5 2 plus root 7 over, now, and that is a 7 just there, negative 3. And again, different ways in which that can be written. I'm thinking the calculator is going to bring the negative out front and potentially expand the brackets. So if we do this one now, we've got on here, let's just go there, we've got 5 over now 2 minus the root of 7. So 2 minus the root of 7, and that gives us now the negative 10 plus 5 root 7 over 3, as this is right here. That's exactly the same value, just written very slightly differently. Okay, so if we go back now and look at the example that we ended up here, what we could do here, and I'll just rewrite this now, what we're going to have is the following. We've got root 3, and then we could write this now as minus 8 plus 2 root 3, or if you want, you could write it as 2 root 3 now minus the 8. I'm going to write it as the negative 8. Let's go ahead. I think it's better to write it in that form. It's entirely up to you. I think it's just slightly easier to see if we do it this way. So what we'll have is negative 8 plus the 2 root 3. So I'm going to now multiply this by negative 8, then we're going to have minus 2 root 3. The advantage here is that you can see the positives and negatives as just a touch easier. So we've got negative 8, and we're going to subtract from that now 2 root 3. Okay, so just leaving the denominator alone for now. If you want, you can take this negative out. I'm going to write it initially as negative root 3, then we're going to have 8 plus 2 root 3. I look at all possible ways that this can be written. Now, what we've got is this number here. This right here, if we squared it or multiplied by 2, is actually going to give us now 12. 2 times 2 is going to give us 4. Root 3 times by root 3 is 3. So you can do this a long way round. You'd have plus 16 root 3 minus 16 root 3. I'm just going to write this as 8 times 8, which is 64, as they're both negatives. And then we're going to get minus 12. Okay, so if we wrote this out, we're going to get minus the root of 3, 8 plus 2 root 3, and that is going to be over now. What's that going to give me? 52. So that's what we get. Now, if we look at this, again, we could tidy this up. We've got now 52, we've got 8 and 2 there, so we could write this now as negative root 3. Dividing numerator and denominator by 2, we could have 4 plus the root of 3 divided by now 20. What's that going to give me? 26 if I half that. If we look at that, I would say that's a nice way of writing it. If we thought about this and we wanted to multiply it out, we could have negative 4 root 3 minus 3. So another way in which this can be written, again using the skills that we have, we could write this as, now on here, I'm going to write it, in fact, let's write it as negative 4 root 3 minus 3 over 26. Let's try it in the calculator. I'm not sure that it's going to like this. It might give us a decimal answer, but we'll have a go anyway. So the root of 3 over now 1 minus the root of 3 multiplied now by 1 plus the root of 27. Hopefully it will be kind to us and default to that mode. There we go, negative 3, negative, right, let's just see what we've got. That's what I've got. So essentially all they've done, all the calculator's done, all they've done is brought the negative out front. But there we go. That's one way of doing that one. Okay, let's go back to where we were. Okay, so we are now, we just did this one right here. These are very, very similar. Now with this one, if you really wanted here, we've got 2 plus root 12. You could write this as now 2 plus 2 root 3 over the 5 minus root 3. You certainly don't have to, and you might argue that it's more advantageous not to. It's entirely up to you. It depends on how you want to see it. You could even write this now as 2 lots of 1 plus the root of 3 over now 5 minus root 3. So if we did it this way, all we would be doing is multiplying the numerator and the denominator by 5 plus root 3. And then 5 plus root 3. Okay, so if we do that, let's go ahead and look at that. So what we're going to get now is the following. So on here, let's just go ahead and check this. Let's see what we're going to get. With this one, the one that we did before simply had a numeric value. I didn't do this one. We can come back to that one. But now all we're going to do is expand this out, both in the numerator and the denominator. So I'll leave my 2 just there for now. And what we're going to have then is 5. Then we're going to have plus 1 root 3 plus 5 root 3, which is going to give me plus 6 root 3. And then we're going to have now in the numerator, we're going to have plus 3. So I've expanded that out 1 times by 5. Then we're going to have 1 lot of root 3, 5 lots of root 3, and then plus 3. And now that is going to be all over 5 minus 3. Again, show workings, but 5 minus 3 is going to give me now, 25 minus 3 is going to give us 22. Okay, so that's what we'd have. Again, if you want to show it, probably, as you can see, I nearly made a mistake. What we've got then is the following. We've got 8 plus 6 root 3, so 8 plus 6 root 3, and that's all over 11. 2 over 22 gives me now 1 over 11. If you want, you could, I suppose, factor this, taking the 2 out, so you can have 4 plus 3 root 3 over 11. So if an exam question asks you to write it in that form, that is what you would get. So let's have a look at what this gives us if we have 2 So 2 plus the root of 12. So 2 plus the root of 12, and then 5 minus the root of 3. So 5 minus the root of 3, and hopefully now that will give us what we've got. 8 plus 6 root 3 over 11. So it's gone for that one, which is perfectly fine. That's exactly what we've got here. You didn't necessarily need to do that. What you could have done is just multiplied this up. So if we started again, we would have 2 plus the root of 12, and we would multiply this now by 5 plus the root of 3. So 5 plus the root of 3, and that would be over now 5 minus the root of 3, and then 5 plus the root of 3. So if we just look now at the numerator, we would get 10, we would get plus 2 root 3, plus 5 root 12, plus the root of 36, all over now the 25 minus 3, which is the 22. At the moment, this looks a complete mess. But if we look here, the root of 36 is 6. 6 plus 10 is 16. Then I've got plus 2 root 3. We've already seen that the root of 12 can be written as 2 root 3. So that becomes plus the 10 root 3. And that again is all over the 22. So we can see that this gives me now the 16 plus 12 root 3 divided by 22. And of course we can halve this. So 8 plus 6 root 3 over 11. So hopefully you can see that with a bit of subtle manipulation, if you like, we don't have to, it can sometimes be a little easier. So that's an example of it. Okay, let's have a go at another one. So what shall we have a go at? Okay, with this one here, again, we could write this as, instead of root 8, 2 root 2. With this one here, what we've got is the root of 2 over now 1 minus the root of 32. This is entirely up to you. You can simply now multiply by 1 plus the root of 32 and 1 plus the root of 32, if you like. It depends if it asks for it in its simplest form. The reason I'm saying this is that the root of 32 is the same as the root of 16 times by 2, which would give us 4 root 2. So just leaving the numerator alone for now, what we'd have is 1 plus the root of 32, and that would be multiplied by root 2. In the denominator, we would have 1 times 1, then of course the difference of squares, so we'd have 1 minus now 32. So we'd end up now with root 2, 1 plus the root of 32 over now negative 31. That's one way in which it can be written. Thinking ahead, the calculator is going to probably have the following. It's probably going to have now the negative out front. We're going to have now the way in which it's going to write it. I think it's going to do the root 2 times by the root 32. That's going to give me root 64, which is 8. Root 64 is 8, plus now root 2 over 31. So if we put that in a calculator, I think that's what it's going to send us to having. So if it was an exam question and it said show that it can be written like this, all we've done is simply use the same skills that we've had previously to do that. So let's go ahead and see if that gives us what we want. So yeah, there we go. It's as expected. So it just gives us that value. Okay, let's have a look at this one right here. So we've got a plus root b. So let's write this down. A plus the root of b over a minus the root of b. We need to multiply the numerator and the denominator by a plus the root of b. So a plus the root of b and a plus the root of b. We saw something similar to this in a previous video. I'm not going to expand this. I'm simply going to write this now as a plus the root of b squared. So all we're doing is squaring this, as we've got two of them multiplied. we're going to have here a squared minus b. And again, we've seen this before. It's this number squared minus this number squared. So a squared minus b. And that's how I'd leave that one. That's very, very neat. Okay, the last sort of examples, we've not really looked at one where we've got a root. So for example, you might have, let's just do 3 plus the root of 2 over the root of 5 plus, let's go for the root of 3. So this time, again, we've got the additional subtraction in the denominator. All we would do here is multiply the numerator and the denominator by the root of 5 minus the root of 3. So again, creating the difference of two squares or multiplying by the conjugate. That word conjugate isn't necessarily massively popular, but I'm just including it for completeness. Okay, looking at this, it's going to be a mess. So we'd have in the numerator 3 lots of the root of 5. Then we'd have minus 3 root 3. Plus, now the root of 5 times by the root of 2, as we've seen before, is the root of 5 times by 2, which is 10. And then the root of 2 times by the root of 3 would give us now minus 6. And that is all going to be over now root 5 minus root 3, which is going to give us 2. Root of 5 squared is 5, root of 3 squared is 3, so we subtract them and we get 2. Looking at this, if it doesn't give us a decimal answer, it will give us something along these lines. I can't see that I can do any more simplification, so let's go ahead and look at that one. So what we've got then is 3 plus the root of 2. Sometimes when these get really messy, these fractions, it gives us a truncated answer, so a decimal answer. But we'll have a go, see if it likes it or not. So there we go, there's our decimal answer. Now if you wanted to check, I suppose this is one way of checking. So if we just subtract from that, let's put if we subtract this away and get 0, we can see that our third answer is at least correct. Now this isn't a very cultured way of checking, but I'm just doing it off the top of my head. So let's go ahead and do that. I think I've got this incorrectly, or in the calculator correctly rather than incorrectly. And let's go that. Hopefully we should have 0. There we go. So that is essentially what we've got. It's just a messy example. So there we go. That's rationalising the denominator of a fraction where surds are involved. We got 2 different scenarios. We had the cases where we had just the single surd in the denominator, where we multiply the numerator and the denominator by that surd and cancel at the end. And then the other particular type we had were when we had a value in the bottom that had a plus or minus between 2 values, and we multiplied by the same numbers but a different sign, or if you like, the conjugate, to create a difference of squares such that the surd in the denominator dropped out and gave us a rational number.